I'm Anil Kumar, and in this video we will learn what are compound events and then classify them as dependent or independent event. Well, most of the time the events are not simple. That is to say, we could have more than one event at the same time. So we can have more than one event. So if you have more than one event, we treat that as a compound event, right? So that is one thing. Now, whenever there are more than one events, then there could be influence of result of one event on the other, right? So that makes things as dependent or independent, right? So what we do is when we say independent events, then the independent events are those, let me write down independent events. So these events where the outcome does not depend directly on the outcome of another, right? So we can say the outcome is not influenced, right? So that is, outcome of one event is not really affecting the outcome of the other. Then we say it is independent event. And in case of dependent event, the outcomes are directly affected. So outcomes are directly affected, right? So those are dependent events. Now, just to take few examples, for example, let us consider the event of tossing a coin. Let's say we toss two coins. We toss two coins and we want to know what is the probability of getting two heads. Now in this case, each event is independent. When you toss a coin, it's 50% chance of getting a head, 50% chances of getting a tail. When you toss them one after the other or both of them together, it doesn't really matter, right? So we have, in such cases, getting two heads means you get one head from the first one and one head from the other. Since it is 50-50, right? Or you could say 1/2. And for the other one also it is 1/2. Now when we say both these events have to happen, in that case the probability of both happening together will be product of these two, right? So that is how we can actually find probability of events which are independent. We apply the product rule. So we have the product rule. Correct? So here the probability of having two heads will be probability of each multiplied, right? So we get 1/4 as our answer. So this is the probability for both the events to happen, that is A and B, correct? Both A and B. That means in the first coin, when you toss, you get head. In the second coin, also when you toss, you get head. Both of them to happen, we multiply them and we get our answer, and this is called the product rule. So in compound events, we are actually multiplying the probability in the two cases. Now here, the example given to you is the one which is of independent event, correct? Now let's take up another example. Let us take a pack of cards, for example. So if I have a pack of cards, so we have standard deck of cards, or you can say deck of cards, okay. 52 cards. And now, what is the probability to draw king and then queen, right? Now this is being done without replacement. So we have two events here. The first event is we have to draw a card, and what's the probability of getting that as a king? And then we will not be replacing that card. And then we draw another card. And what is the probability of getting that as a queen? Correct? So that becomes a dependent event. It is clearly dependent because once you have a pack of 52 cards, there are 4 kings, right? There are 4 kings and 52 cards, right? But as soon as you withdraw one, in that case, number of cards decrease to 51 cards. Is that okay? There could be, so since the number of cards have changed, the result for getting the queen will change. Correct? It becomes more probable, right? You have lesser number of cards and still we have 4 queens, right? So in this case, the probability changes. But important thing here is the product rule will be applied since AND operation is there. So whenever we have such events which are dependent or independent, product rule is applied, right? And we have to see what really happens, right? In this case, the probability will be 4 out of 52. So this answer will be 4 out of 52. That is for withdrawing, getting a king, times 4 over 51. That is to get a queen. You get an idea, right? You can always multiply and simplify to get the result, right? So we are not getting there, but I hope you understand what are we talking about, correct? So we have a pack of cards. We're just drawing one card followed by another card, right? So we are having a standard pack of 52 cards. So 2 cards, one after the other, are drawn, and then we have to see whether it is independent or a dependent event. So this is an example of dependent event, right? So now here is a question for you. Now we draw 2 cards, right? If we draw 2 cards with replacement, in that case, will the event be independent or dependent? What I'm trying to say is you draw a card and then you put it back into the deck and then you draw the other one. In that case, you know clearly it is independent event since the first card which was drawn has been placed back, right? So that becomes independent event, right? So the key word in this is whether the card was replaced with replacement or without replacement. So these two events, when you combine, if the cards are not being replaced, then the outcomes are directly affected and therefore it is a dependent event. But if you replace the card, then it's like a fresh deck of cards with 52. It's independent, as if it doesn't really matter which operation is done first. You get it? So in this case, the probability will be 4 over 52 times 4 over 52. Do you see that? Well, important thing is, if the events are dependent or independent, product rule is applied, right? So in any case, product rule will be applied. However, you will have to look carefully into the example and then solve. So it's kind of a critical thinking. So first question always which should come to your mind is, in this case of compound events, is the event independent or dependent? And then you can apply the product rule and find the solution. I'm Anil Kumar, and I hope that gives you a good introduction on dependent, independent events, and we'll take a few more questions based on this. Thank you and all the best.